Okay, now we move to Born-Haber cycle. Okay, Born-Haber cycle is named as two German scientists that is referred to Max Born and Fritz Haber, combination of both German scientists. So Born-Haber cycle is an approach to analyze reaction energies that shows the energy cycle for ionic compounds. So actually it was usually primarily as a means to calculating lattice energy. Okay, which cannot otherwise be measured directly. So which means lattice energy is we cannot calculate it directly. So it involves a series of enthalpies. So Born-Haber cycle connects enthalpy of formation with lattice energy. So actually there are a few enthalpy that will be connected with lattice energy. Okay, alright. So two methods that we can apply that is referred to energy cycle method and energy level diagram. For example, find the lattice energy for the following result. So usually dalam exam dia akan bagi data begini. So equation dia tak bagi dalam soalan. Jadi maksudnya you all kena hafal setiap satu definition yang terlibat. Apa yang terlibat? Enthalpy of atomization, ionization energy, and then electron affinity, enthalpy of formation, and one more is lattice energy. So meaning that ada 1, 2, 3, 4, 5. 5 type of enthalpy kena hafal definition. So bila kita hafal definition, so ini akan memudahkan you all tulis equation dia. Okay. Alright, so now bila bagi data begini, kita boleh start dengan tulis equation bagi setiap satu enthalpy. Okay. Alright, so kita start dengan enthalpy of atomization of potassium. Right, so sini kita nak hasilkan potassium in gas. Yang ni supposed to be 1 mole. So it comes from its element that is K that exists in solid. So dapatlah equation yang pertama. So ionization energy of potassium. So it should come from gaseous ion. Okay, remove one electron and produce K plus gas. Okay, the electron at the product side. Atomization of chlorine, which means we want to form 1 mole of Cl gas from its element. So element is exists Cl2 in gas. So nak balance, kena balance kat depan ni. Time half. Okay, electron affinity, which means it's come from Cl gas gain 1 electron and it will produce Cl minus gas. Okay, next enthalpy of formation of potassium chloride. Okay, enthalpy of formation, which means you want to produce 1 KCl that exists in solid from its element. So which means from K solid and from Cl. Cl exists as gas. Remember? Cl2 gas. So ini mesti 1 mol. Jadi sini mesti darab separuh, setengah. Okay, and then kita recap balik for halogen. Okay, Cl2 exists in gas. F2 also in gas. Okay, bromine, liquid. Okay, iodine is in solid. So ini you kena ingat je, kena hafal. Okay. Alright, so settle. First step, you write all the equation for the enthalpy involved. Alright, next, what should we do? So first, you have to write the enthalpy of formation equation. Okay, mass level on top of the arrow. Okay, and then from the metal here, so it will undergo atomization. Okay, K plus produce K gas. And then level delta H atomization. The value here is positive 90 kilojoule. Remember, you have to include all the phase with correct coefficient, balance, and label all the delta H value. Gaseous atom produce gaseous ion. This is referring to IE. Okay, ionization energy. So positive 418 kilojoule. So meaning that for metal here, daripada solid ni sampai dia dapat ion. Okay. And then for Cl2 gas, so first of all, it undergoes atomization. Molecule, dia akan tukar jadi Cl gas. Okay. So value here is positive 121 kilojoule. Daripada gases atom, gain 1 electron and produce Cl minus gas. So this is referred to Ea. Jadi negative ion. So negative 364 kilojoule. And then tambah. Then you get this. Is referred to delta H. That is that we want to find out berapa nilai dia. Okay, alright. Okay, next tulis relationship. So delta HF actually is sum of the other 1, 2, 3, 4, 5. 5 enthalpy. So delta HA for potassium, okay, plus IE plus delta HA for Cl plus EA plus delta H, that is. So this is the relationship. And then substitute all the values. So you want to find out delta H, that is. Okay, therefore, when you calculate the value of delta H, that is equals to negative 701 kilojoule per mole. So unit here should be in kilojoule per mole because it's from 1 mole of KCl in solid. Okay, we move to the next example. Okay, construct a Born-Haber cycle for the formation of magnesium fluoride MgF2 by using the data below. So here all the data. Okay, based on the Born-Haber cycle, determine the lattice energy of magnesium fluoride. So from this question, doesn't mention what method to use. So you can choose whether solve it by using energy cycle method or you can choose energy level diagram. But I'm going to show you energy cycle method. Okay. Alright, so you can start by writing the equation involved in the Born-Haber cycle. So we start with enthalpy of atomization of magnesium. So remember, atomization means we want to produce 1 mole of gaseous atom. So it comes from its element. So Mg exists as solid. Okay. Atomization of fluorine. So become fluorine atom. Should be 1 mole. Okay. It comes from its element that F2 that exists in gas. Bahagian produk mesti 1 mole. Jadi bahagian reactant, so kita balancekan. Time half. Okay. So first ionization of magnesium, so it should be from Mg, so Mg gas, okay, become Mg plus 1 electron. Okay, second ionization means from Mg plus gas, okay, produce Mg2 plus gas. So electron affinity meaning that from fluorine atom, okay, so accept 1 electron and it will produce F minus ion. Okay, enthalpy of formation, you want to produce MgF2 that is in solid. Okay, so the product side should be 1 mole. So came from its element, which means Mg solid plus F2 exists in gas. Alright, so and then check whether the equation is balanced. So equation is already balanced. So this one should be 1 mole. Alright, so settle for the equation. Alright, so we start with enthalpy of formation. Right, so don't forget to label with the correct unit. Alright, next atomization for magnesium. Okay, next, first IE first become Mg plus. Okay, IE first. Right, next, Mg2 plus, second IE. Alright, so remember, so from metal until become ion, sampai jadi ion, one complete set. And then we move to the non-metal, which refer to F2 gas. Right, so first it undergoes atomization, F gas. So we want to produce F gas, and then this is not balanced yet. So when refer to this equation, so this is 1 mole of F2 gas. So and then it should have 2 mole of F atom. So for atomization of fluorine, so meaning that it produced 1 mole of fluorine atom in gas. Okay, so the value here is positive 159. However, in our Born-Haber cycle, because we need the reactant here, F2 should be 1 mole. Okay, because this equation is referring to the enthalpy of formation. Ini equation ni dah balance dah. Ini memang dah already balance. Jadi ini mesti 1 mole. Disebabkan ini 1 mole, so kita kena balance kat equation ini. So that's why ini jadi 2 mole. So because 2 mole, so kita dah ubah coefficient dia. So therefore the value of delta HA for fluorine changes. Okay, so you have to times 2. So you will get here positive 318. This one need 2 mole. Okay, in the data given in the question is only for 1 mole of fluorine atom in gas. After become fluorine atom, so it become fluorine ions. Okay, F minus gas. Right, so we have to balance, so times 2, and this is what we call EA. Okay, when refer to the previous slide, 1 F atom in gas accept 1 electron and it will produce F minus gas. Okay, the value here is negative 328 kilojoule per mole. However, in our Born-Haber cycle, we need 2 mole. Okay, that's why EA also you have to times 2. Okay, and then you will get here. Okay, next step, just add both gases ion. Okay, and it will produce MgF2. This is what we call delta H, lattice energy. And this is what we want to calculate. Alright, so next, write the relationship delta HF plus delta H lattice. So, kena tulis ada markah here. And then, you substitute. Just press your calculator. Suppose you get delta H lattice here is equal to negative 3121 kilojoule per mole. So the final unit should be in kilojoule per mole. Why? Because this is referring to the lattice energy. So means lattice formation form 1 mole of MgF2. So therefore the unit should be in kilojoule per mole. Okay, so this one this example. Okay, construct a Born-Haber cycle for the formation of sodium chloride in HCl by using the data below. So this is the data. So based on Born-Haber cycle, determine the lattice energy of sodium chloride. So doesn't mention to you which method to use, but because I already show to you 2 example using energy cycle method. For this time, I would like to use energy level diagram. Okay, but first, what should we do? So first, we have to write the equation involved. Okay, we start with enthalpy of formation. So formation here means we want to produce NaCl, which is solid, which came from its element, that is Na is in solid, and Cl2 gas. So this one mesti 1 mole, so kena balance di depan ni. So this one times half. Okay, so that is for refer to the enthalpy of formation. So enthalpy of sublimation is the same as enthalpy of atomization, sama je. So sublimation means from solid become gas. Na gas. So actually this one is also what we call enthalpy of atomization. Okay, first ionization energy of Na. So meaning that from Na gas, remove one electron and produce Na plus gas plus one electron. Okay, enthalpy of atomization of chlorine. So which means from Cl gas. So from Cl2 gas, Cl2 should be in molecule, become Cl gas. So this one should be bond. So therefore you have to bear it in front here, time half. Okay, electron affinity of Cl, which means Cl gas gain one electron. So it will produce Cl minus ion in gas. Okay, lattice energy for NaCl. So this is what we want to find out. Okay. Alright, so the next step. Alright, so we start with drawing the, what is this? This label enthalpy. Alright, and then we draw a platform like this. So start with enthalpy of formation. So enthalpy of formation. Okay, so it comes from Na solid plus half Cl2 gas. Okay, and then it should be 1 mole because enthalpy of formation is negative value. So you have to draw arrow downward to show heat release. And don't forget to label this delta HF is equals to negative 411 kilojoule per mole. Right, so second, we move to atomization of sodium. We draw a platform. Okay, platform wajib lukis ya. So draw arrow upwards, point upwards from sodium. Alright, okay, why? Because we want to show enthalpy of atomization of sodium and the value of delta HA is positive. That's why you have to draw arrow upwards. Okay, value is positive 108. Okay, from Na solid now become Na gas. As for the chlorine, it remain unchanged. Just copy it back. Right, next we move to the atomization of chlorine. Draw another platform like this. And then arrow upwards from Cl2 and label delta HA positive value. That's why arrow upwards. Alright, so for sodium, atom in gas does not change. Just copy it back. So from half Cl2, now become Cl gas. Right, next is IE for and is gas. Okay, make sure large difference here. Okay, because IE here, the difference is IE here is positive 500. Jadi jarak dia mesti besar lah. Jarak dari sini, satu platform ni dengan platform ni mesti besar lah. Okay. Right, so from Na gas, now become Na plus gas. As for the chlorine, does not change. Just copy it back. Alright, so next is Ea. So Ea for chlorine. So Ea is around negative 364. So mestilah tak selari dengan yang mesti atas sikit. Di sini. Okay. Right, so copy it back for Na plus gas. Okay, plus Cl minus gas. Because it gain 1 electron. And then arrow downwards. And then label, this is Ea. Negative 364 kilojoule per mole. Alright, next, the final step is you have to draw from here, point downwards. This one is to show delta H lattice. This is what we are going to calculate. Right, next, what should we do? So first of all, write the relationship. F is equals to next step, substitute. Okay, and finally, when you calculate the value of lattice energy, suppose you get negative 777. And don't forget to write the final unit, that is kilojoule per mole. Okay, so please remember, bear it in your mind. Untuk topik ini, semua face consider. Kena tulis. Okay. And then coefficient equation tu mesti balance. Okay, kalau untuk energy level diagram mesti lukis platform wajib. Okay, arrow up, up, up because enthalpy is positive value. Okay, arrow down, down, down. Why? Because enthalpy delta H is negative heat release. Okay, right? Okay. Alright, so that's all for today. We have reached the end of topic thermochemistry. So hopefully you can answer all the tutorial problem. If you have problem, don't hesitate to ask me. Okay, that's all. See you again in the next chapter. Bye and Assalamualaikum.